Today we are only doing just the one example for 9.3. I think the questions in the textbook might be a little less difficult than this one here. It's still a good idea for you guys to get the experience of these sort of questions. So when we're sketching a graph, the key word is sketching, obviously. There's only two words you can choose from. But when we're sketching, it does not need to be um, like exact. You don't have to physically get every little point lined up on your ruler. You're only after the main points. Now, with this sine graph, with your finger, can everyone trace the sine graph right now? I want to see. Okay. Okay, good. Now, can everyone do a cosine graph for me right now? Good. Does anyone know what a tangent does? Has anyone seen one? Very good. Okay. We're not going to touch that today. We're just going to stick to the sine. I gave a tip last term about how we should approach sketching graphs. When I got you to trace it out, what's the tip? Am I really asking you to do when we're sketching y equals 5 sine x plus pi and 4 and 4? What's the basic technique? What's the first step? Did anyone remember what I said last term?
Find the period.
Find the period. Not quite. No. Good try. Okay.
Just draw the basic one.
Good. Good. Good, Perry. Draw the basic one. All we're going to do is just draw the basic one right here. So we've got this. Everyone was shown right now that with your finger, that's our sine graph. Now, using our basic graph, what would be the next thing we could label on our graph here?
The y-axis.
The y-axis, okay. What would I put up here, Tim?
5.
5. And down here, a negative 5. Okay, we're halfway there. And we know, does anyone know what's happening at point 1 and what's happening at point 2 of our equation? What's a positive 4 doing, Nathan? A positive 4 here. What does that do to a graph? Raising it up. So translate positive 4 units. And that's in an up and down fashion. Whenever you see a bracket inside and a plus something, does anyone know what that's doing there? Jesse, do you know? A plus pi on 4. Okay. It's similar, the same rules apply like when you did quadratics. Remember, you had that. What was that 2 doing? It's a left to right. Okay. Same rules apply. So which way is this one going? The -2. Is it going right or left? It's going right. In the same way, we have a plus pi and 4. So we're shifting left pi and 4 units. And they're the things that we need to draw right now on here. Okay? So what we're going to do, this point here and this point here. Emily, what's halfway?
It's the x-intercept.
It's the x-intercept, good. And Tim alluded to a period. What's our period equation, Emily? Do you remember?
No.
It's okay.
2 pi.
2 pi on n. Can someone tell me what the n is? Zach, there's an n somewhere here. What is it? Very good. is standing right there, and you didn't see it. Zach's the one. 2 pi and n. So 2 pi on 1. So if I have a period of 2 pi z, what does the period of 2 pi really mean in regards to a sine graph?
Um, well, 1 pi is like one, like go up and down.
Are you sure? Remember, you're close, but not quite. That's one cycle. Okay, so if I have one cycle of 2 pi, then one cycle is 2 pi right here.
Okay.
So therefore, what's in here, Z?
1 pi.
1 pi. Okay. What are the helpful marks on our x-axis can we put?
Pi on 2 at the top.
Pi on 2 at the top, so the pi on 2 is back here. Okay. We can have 3 pi on 2 up here. Any other dashes that could help us by looking at our equation? If x is the shift from left to right, what's another good increment based on our equation that we can highlight on our x-axis? We've got ones, we've got halves, but we could also have quarters because we've got a quarter here. So therefore, I'm going to cut this guy up here, pi and 4. Okay. What's this one here?
3 pi.
3 pi and 4. So all your fraction work from before is now being used in here. So therefore, what's this one in here?
5 pi 4.
5 pi and 4. And you can see by looking at the first dash, that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi and 4. Okay. And what about in here? If this is 5 pi and 4, what's this one? 7 pi and 4, and so on. I'm not going to go further here. We can, but remember, we are going left. So therefore, my voice just cracked. I'm going to make sure that I've got pi's on 4s this way here. And that's our negative, and that's our 0. Okay. So what we do now, we're just going to shift the whole thing. So I'm just going to get my eraser, and we're going to go left. So before we do that, if this was our original, so everything else, where's this guy going to move to? At what?
3 pi 4.
3 pi and 4. Where's this guy going to go to?
7 pi 4.
7 pi and 4. This one? Pi and 4. Okay. So therefore, we've got a few guidelines to help us to graph this next one like so. And it's going to be a bit messy, but hopefully it still makes sense. So let's get rid of that. I suggest that you use a pencil if you're doing things this way. So you can shift. Okay. So that's no longer needed. Still pi though. Okay. What are we going to do now?
Not by 4.
Going to move it up by 4. Okay. Alright. Let's get cracking with this question. I'm just going to Move it up by 4. It's going to be a bit tricky because I made it to. I need to draw this on the wall if I want to do this. So let's go. Just give me 1 minute to establish this. All right. There's your 5 there. -5 here. Still the same graph. Just change the axis. All right. This point here, just going to use a few cheats as we go. And this point here, top of the hill. This hill is going to move to what point? Is that
9.
9? Okay, good. I'll put 10 there. Okay, this point here, okay,
It's going to move to 4.
going to move to 4. This point here, Emily,
We'll move to 4.
move to 4. And this one, 10. Where's that going? 4. So now we've shifted it. Oh, we missed one. This one here, Nathan, going to negative.
-1.
Great, thank you. So we go this here, bang, and we're going to sort of go up like that. In a different color, I'm going to put in blue the parts of a graph with a sine graph or trigonometry. What am I going to, where am I going to put my features of what we need to work out? Okay. Which ones are there? Can you see them? So I'm going to go up to here. You're going to color in all your x-intercepts and y-intercepts, and they're the ones that we're going to try and calculate now. We're not so much interested in these because we haven't done what topic allows us to calculate on paper our tops and bottoms.
Calculus.
It's calculus. Okay, we're not there yet. You'll be asked to do that bit later on. Okay, so let's go. X-intercepts. Get your calculators out, please. What mode are we making sure our calculator is today? What's our mode? Radian or degree? Radian. So make sure it's in radian. In here, I'm going to rewrite this. But as you do with any graph, if I want to find x-intercept, what changes in here? The 0. Y becomes 0. Because that's where all the x-intercepts live. Okay. What's the first thing that we want to tackle in backtracking? Try and get back to the x, the 4. What's the next thing that we should tackle, Gabe?
5.
The 5. Okay. What's the next thing do you think we should tackle, Perry? The inverse? Inverse. Okay. All right. Thanks, Perry.
Between -4 and -5 brackets of the sign.
Good. Now, that's right, Gabe. Remember, we must always use our cuts. And as Gabe was highlighting negatives, there's another way we could highlight negatives on here. In which quadrant is our sign a negative? and C. Okay. Can everyone see that? So we can just, even though we ignore the negative, we're going to make sure we look for the negative in our diagram, because these are the negatives. If you punch in right now an inverse sign on 4 and a 5, what do you get? Someone tell me.
0.9.
0.93. Now, with trigonometry, it's best to go to 4 decimal places. Please go to 4. It's a little bit more accurate. Okay, what does that mean? When we go around in a circle, by symmetry, 0.9273 and 0.9273. And we are reading, remember, from here and from there. We never read from the top and the bottom. So if we keep going, I've got 0.9273 there. I can rewrite this. Just rewriting this now. But if I'm going from 0 to 2 pi, I hit this one. What's this here?
Pi.
It's a pi. I keep going round here. Say, what do I need to do to the 0.29273?
Make it negative.
Make it negative. We can make it negative. There's another way though. What if I go around here, say, where am I at? If I go one full circle,
4 pi.
not 4 pi,
Oh, yeah, 2 pi.
2 pi, but we're going back. So in front, what will you put in front of this?
Just 2 pi.
2 pi. What's the sign if we're going back? Minus. Okay, almost there. We go again. In your calculator, can everyone press pi plus 0.9273? Does someone have the answer right now?
Oh, 4.0688.
4.0689. And the second one should be 5.3559. We're not quite there yet. What's the last thing that we need to do to get our x?
Plus.
Yep, so we get rid of that. Opposite of a plus is a minus pi and 4. And we do it with the same one. 3559 minus pi and 4. On your calculator, if I haven't made a mistake, it should be 3.2835, 4.5705 as the x-intercepts. Okay. Lastly, make sure you label, don't lose marks. Once you do all the working out, if the question asks you to label on the sack, you must label. So therefore, if I'm going to label this, this first blue one is our 3.2, obviously. What do I put? What matches up with this? 0. And this one over here, okay? Last step is our y-intercept. X equals 0. Our x changes to 0. Okay. Does anyone know what a sine pi 4 as a number? Looking at the angle,
One.
one what?
One over. Oh, I have two. Two. Root 2 over 2.
Okay, so root 2 on 2, or you can have the 1 on root 2. They're both the same. If they asked you to leave it an exact, you'd probably leave it like that. You could do a bit more work there, but let's just do decimals today. You could have 7.5355, and it works out over here that this is our 7.5355. Okay. Right now, you're not expected to hit your highs and lows, just the x and the y intercepts with the working out. Obviously, if the SAC, which I'll clarify later, if it's non-calc, you're going to have to do everything using your triangles that you know in your head and leave things in exact values. Okay, be careful. Some of these questions go to degree. So make sure your calculator's in degree mode because you'll get a totally incorrect answer if it's in radian